Hello there. Welcome to our final session. Today we're going to wrap up relocation. It's a very straightforward, easy sort of a class. And I do want to go over some fundamental concepts with respect to just some basic stuff that we sort of brush over but don't really get the chance to cover in too much detail. Alright, so let's kick things off with some basic vocabulary. And so the point that I want to make today is called the identity element. Now, the identity element, it basically doesn't do anything, right? It's an element that keeps the identity of what came before it. So let me give you an example. Let's look at the case of addition, right? Let's say we do like 5 plus 0. I think the example here I have is 0 plus anything. But let's say we do 5 plus 0. 5 plus 0 equals 5, which means the act of adding 0 didn't do anything to 5. Hence, we say that 0, as it says right here, is the identity element of addition. Likewise, in the case of multiplication, 1 times anything gives you whatever it was. And so 1, we say, is the identity element of multiplication. Generally, we only have one identity element for each set of operations, so subtraction and division don't typically have identity elements the way that addition and multiplication do. Okay. What are the applications of the identity element? Well, you already know this, but basically every number goes with the sign before it. So 5, for example, is being multiplied, 2, for example, is being divided, 4, for example, again, is being multiplied, 2, for example, is being multiplied. But what about this 7 at the beginning, which doesn't have any sign before it? Well, I say that this has a hidden multiplication, which means, because obviously it's not 8 or 10, the 7 isn't being added to anything or multiplied by anything, so we say it's being multiplied by 1. Division doesn't have an identity element, and we're not adding here, so it only makes sense to say, okay, you can think of there as being a 1 times 7. Actually, why don't we write that down? I'm going to try and using the pen here. So you can imagine there's actually a 1 multiplied by 7 right here, right? And that's why we say that there's a multiplication sign that's basically hidden, because we don't typically write this, right? And that's not typically needed. Now, what is the evidence for this? Well, let's look at this a different way. So if we basically turn to over here, let me get my laser pointer back. If we turn to over here, you know this calculation here, 7 divided by 7 equals to 1, right? And this is why the identity element is multiplication, because if there was a division sign here, we would be dividing by 7 twice. That's not what's happening. We're taking 7 and dividing it by 7 only once, right? So that is the reason why the identity element remains to be multiplication. Okay, so this is an important application. We brush over this and it's not that important, but you know what? Now it's been said and now you'll know exactly what that is. So how does relocation work in the context of signed numbers? Well, we combine basically what we know about relocation and signed numbers and solve them together. So I have here this little table made, and this is a really good guide on what to do, right? So where I have this plus and minus, this is to represent signed numbers. And this switching here is to represent relocation and moving things around to calculate things properly, right? So in problems involving addition and subtraction, what I like to do is evaluate and combine all the adjacent signs first. And then at the end, we relocate. On the other hand, with respect to multiplication and division, as it says right here, I would like you to first apply the sign numbers, and then solve the question with the actual relocation properties, right? So basically, you'll want to, first of all, you can do this at the end as well, but basically you want to apply the sign numbers first, and then go ahead and solve the actual problem using relocation. Okay? So I've just made this little flowchart to basically show you what to do in that case, right? Again, it's always easier to sort out all kinds of weird signs first, and then just relocate and find the answer. And again, this depends a lot on your use case, but yeah, in multiplication and division, honestly, it doesn't matter too much. As long as you end up with the right answer, you can relocate first and then decide on your sign at the very end. But you can also decide on your sign at the very beginning and then relocate. It doesn't really matter what stage this is in. So basically, this here is interchangeable pretty much. But with addition and division, I do want you to follow what we talked about. Right. So this is relatively interchangeable, but addition and subtraction is much easier if we just solve the adjacent signs first. So usually I show you what I mean right away, but these are actually pretty manageable questions. I think you can really take a crack at these on your own. So I have your practice question 1 and practice question 2, and I'd like you to first just try these questions on your own, and then we will take them up. If you need to go back to the previous slide, you can definitely just rewind the video, and you can definitely review the policies on that page as well. Okay, I will see you in 5 minutes. Take care and good luck. All right, so that is time. Before we move on, I would like to go back to the previous slide because I do believe I made a small mistake while describing this to you. And this mistake here is actually in this portion here. So the text here is correct. I do want you to apply the sign numbers first. And so let's change that quickly in the PowerPoint here. I want you to apply this first, and then I'd like you to apply this. Okay. So either way, I'm going to start from the current slide. Either way, I would like you to start with the sign numbers. It's just that in the case of addition and subtraction, you really want to combine the adjacent signs, right? So over here, let's go ahead and just write this out for you. That way it's easier. And I do apologize if you already did the second part and you're coming back and watching this part and saying, hey, this is a little bit incorrect. That is true. I did goof up a little bit, so let's quickly clarify that. For addition and subtraction, remember you're going to focus on the adjacent signs. Right? It's written here as well that you do need to focus on the adjacent signs, but I want to make that very, very clear to you because that is where you're going to be applying your pluses and your minuses to the adjacent signs, the signs right next to other signs. For multiplication and division, on the other hand, over here you will be working with the entire signs at the end. Right? So you do not need to worry about adjacent signs in this case, but either way, you must process the sign numbers first. So always take care of signs first. Okay? And I do apologize. The previous part where I said it doesn't matter is technically wrong. I do want you to follow this protocol, and I will show you why in just a second. Okay, so let's now go ahead and take this up. Now, these are pretty easy questions. Let's first of all remove the timer. I think that'll just get in. Actually, we'll keep it there. We'll keep it there for now. I don't think it'll get in the way too much. So for the first question there, first of all, let's consolidate the adjacent signs, right? So start by consolidating. Oops, that is consolidate adjacent signs. Right? Now, where are our adjacent signs in this problem? Well, we have a whole bunch of signs here, we have a whole bunch of signs here, and we have a whole bunch of signs here. So let's basically figure this out, right? So in this case, we're going to have 25. 3 negatives make a negative, so we're going to put a negative sign here. 15 can stay the way it is. Then we have 4 negative signs, which of course makes a positive. So we will put the positive sign in there. Then we've got 19. And then another positive sign because the 2 negatives there do make a positive. And 11. Now we can actually go ahead and regroup. So this is equal to, let's stick with the royal blue here. 25 minus 15 is equal to 10. 19 plus 11 is equal to 30 because 19 plus 1 is 20 and 20 plus 10 is equal to 30. This gives us a final answer of 40. Of course, we need to check this using the calculator. So I have 25 minus 15 plus 19 plus 11, which gives us an answer right there of 40. Okay? Let's go ahead now to practice question number 2. Now, like I said, in this case, you don't have to actually worry about the adjacent signs. Just worry about all the signs. So we have negative, 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 and 3 negatives give us a negative overall at the end of the day. Now, simply rewrite the question as if there was no negative sign to begin with, right? So we have 5 times 8 divide by 2 times 4. Of course, one can evaluate this mentally, but we can use our relocation techniques. And this gives us 8 divided by 2. times 4 times 5. 8 divided by 2 is, of course, 4. 4 times 4 gives us 16. 16 times 5. I can't do that mentally, so I'm going to go back and try something else. Let's start with 4. So 4 divided by 2, that gives us 2. 2 times 5 gives us 10. And 10 times 8 gives us 80. That I can do in my head. So that gives us an answer of 80. Let's check and make sure we are correct. But before we do that, of course, we need to put the negative sign in there. Because remember, as we said, our final answer is going to be negative. Again, 4 divided by 2 times 5 times 8 gives us an answer of 80. And of course, we know this is negative, not because of the actual calculation, but because of the signs in the question at this stage. Okay? That's it. Like I said, nice, easy, quick class. Have a fantastic rest of your summer. And don't forget to keep practicing math. All right? For the last time this summer, signing off.